Right, so first off, after lunch, we're going to have a talk called Observability Matters, Empowering Python Developers with OpenTelemetry from Yash Verma, and it's not in person, so I'm going to press play.
So to re-energize ourselves and to recollect from where we left, so the last we talked about Python and the future of medtech. That was a really amazing talk. Thank you. And I hope you are really enjoying this session so far because we have some amazing topics and most important, the passionate of developers here presenting you about their topics which they are really interested in and care about. So I initially planned to attend this conference in person. However, due to some other work constraint, I'm here presenting this session from this side of the screen, which I guess somewhat, attending in person is quite interesting, I believe. However, this thing is also working for me. But anyways, let's move ahead. So this talk is about title as Observability Matters, Empowering Python Developers with OpenTelemetry. So first of all, there's one question that why are we even talking about observability at the first place? Well, because it has never been so important and has never been so complex at the same time. Because, and I have been in the conference where people are completely unaware what is observability and what is even, and many of them had not even heard about the project OpenTelemetry. So they have completely no idea what is this. So if that's the case, I will, to be on the safer side, let's start from scratch, so that we could align everyone on the same page. So first of all, we'll start everything from the basics, exploring from the, the basic evolution, how the observability has evolved with time and how it is, the behaving in the present times and what's the future of that thing. So my name is Yash Verma. I'm a software engineer and a researcher. I'm passionate about distributed systems, performance, and observability for sure. I call myself an OpenTelemetry enthusiast. I'm one of the contributors to the project. And, when I'm not involved in my usual tech, I really enjoy cooking, and biking is one of my sidecar. This is my pretty dog. His name is Tai. And yeah, I am a dog lover too. So today's agenda would be as follows. First, we'll witness the evolution of observability, what we call, I would say, the modern observability. Then we will understand the different telemetry signals, moving on with the challenges with the modern setup from a developer's perspective. Then we will understand that why the project like OpenTelemetry even exists in today's, today's time. Then we will have a deeper understanding of the core components of the OpenTelemetry. Following which, we'll understand a Python-specific code demonstration, how to get started, and finally we'll talk about the long-term vision of the project and how to get involved with within the OpenTelemetry community. So let's get back to around the time around 2000 when metrics were used to ruled the world. If at that time, if you would have asked anyone that what you are doing to gain visibility into our system, the only thing they would say that we are employing different monitoring tools, or I would say, we are employing different metric to keep a watch on our, our storage or our entire system. The metrics were so popular at that time. This could be because around that time, storage was quite expensive and metrics was certainly cheaper to store. However, I haven't been into that time, the time where people used to spend thousands of dollars here just to buy a small, the MB of memory. So, but I have seen floppy disk in my first grade in my school. So I believe myself as a fortunate one who has seen the floppy disk. I guess I have seen that, but many of my friends haven't got a chance to see the floppy disk also, right? So moving back to the topic, around that time, when someone talks about, metrics, so it was all about the graph filled with lines having different colors and numbers to monitor our system. Then fast forward to the 2010, when when we began to see the origins of what we call now the modern observability. During this time, Facebook was really emerging as a major force in social media, and they were really hitting some performance issue and struggled to manage their system at scale. To address this challenge, the team at Facebook came up with an idea or built a solution which they called Scuba. So Scuba was designed to work on an arbitrary data, what Facebook called them as a wide events. So basically, it enables them to query any context and graph virtually and about anything to get a deeper insight of their, a performance issue which they are getting. For example, we can say that when someone, when a person is in the Japan and they are comfortably able to log in the Facebook, but the very next day when they land to the US, things were not happening as smooth as they used to be happening in Japan. So, things like this thing only happened in that case. So, to get the visibility of why this thing happened or why this thing failed in this particular geolocation is something which was really a topic of concern for Facebook at that time. This detailed level of insight was possible to get all because of the wide events. And then that time, Facebook was, I guess, only the one company which was doing that thing at particular scale, just because they have some really good amount of cash in there. So I have attached a few research paper and related articles. If you really want to read about the Scuba project, please go ahead and watch it or read it. It's a really amazing project, and people till now also talk about how they are passionate about those things at that time. So now we came to an era that a few years later, the concept of logging at scale and this thing like time series databases emerged. Projects like InfluxDB and Prometheus focused on storing the low level, or I would say low cardinality metrics and aggregation to produce monitoring outputs. Then came the logging tools like Logstash, the entire ELK stack, I would say. So moreover, the emergence of this stack became so popular for storing and searching and visualizing various type of system-related data that everyone was running behind this thing. The evolution made it easier for many people to gain insights into their system now at a very, a very comfortable position. So it was around 2017 we began to see of what we now called modern observability. The things like distributed tracing began to emerge as a popular thing in the software world. Just because the earlier our application used to have a simple front end and a decent amount of backend data, and the data was not huge in its nature. However, over time, our modern applications are built distributed in nature from day one itself, which has an interactive front end and requires a high reliable backend to support it. With the rise of cloud native architecture, things became more portable and extendable. However, they also grew in complexity, which was enough to frustrate a passionate of developer. And just because we started deploying things to an environment that we don't have full control, we also have to think in the direction that now, with the huge amount of data, we cannot afford, or I would say it's not reliable. I would say it's not efficient enough to set up a data center in our, in-house data center at our office. However, this complexity led us to a fear of breaking production systems because we are now working with the cloud native architecture. Things like how could we be sure that if we push something to production, it will not break things and it will not affect, or it will not have a ripple effect to the other codes as well. So, but we also have to believe in the fact that production is the only place which helps us or which enables us to deliver our values to our users. Without production, we cannot deliver our values to them. So production should not be a scary place for some reason. It is to be. I believe it should be understood as a fact that it's a simple extension of our team. And this is where observability steps in, as it helps us to understand the production systems through various signals. Like we can ask things like, what is happening, or why is something not working as expected? Observability provides us with that answer. I would say observability is a bigger umbrella under which we have several other signals like logs, metrics, traces, events, and more. Like many of us are already aware of these, some basic things like logs and metrics. So we'll quickly move on to the distributed tracing part. So, let's talk about distributed tracing. Like it's like imagine an application. So this could be a look of a distributed trace, which looks like. So imagine an application have a network of roads, right? A user's request travels these roads, stopping at many points. At each stop, I would say a data is recorded about what happened. Some of these data include some basic HTTPS status code like 500 errors or 200 responses with a high latency. Other record more detailed data like by their devices, geolocation, or where the user is heading towards. Like face issues with the services like payments after, like if I refresh the page, did I face an issue with the payments? These events can reveal which component slows down in the flow and triggers the other operation. To capture this events, we use a span. Span is a record. A span is a record of one action in our system. Span are the building blocks of a trace. Each span consists of each span represents a discrete operation. It carries a name it carries a trace ID that is linked to a larger journey, and it has a set of tags and has other context. You know, and a span may refer to a parent span if there is a part of a longer operation, uh, or it has a root span if it's the first of its kind. Additionally, span have this log events recorded within the operation, like when does the operation start or ends, and includes every other metadata. And this we can implement in there through specific instrumentation. So distributed tracing is a process of somewhat collecting spans from different services. So this is a sample span, you can see that, which has all the data which we discussed earlier. So when we see from a higher view, distributed tracing is a process of collecting these spans from distributed from different services and linking them together through a mechanism which is called context propagation. This creates a complete view of how a request travels through a system. Later, these kind of trace level data can be visualized in the form of heat maps or service graph, or even to service level objective dashboards, SLO dashboards, which could provide us with an insight into our system performance and how are the users interacting with our system. This level of visibility is a key that helps us to quickly pinpoint the bottleneck and performance issue, thereby reducing the MTTR. However, moving forward, by 2017, there is this too popular open source project called OpenTracing and OpenCensus, aimed to standardize the distributed tracing world. At that time, various vendors were offering their own proprietary instrumentation method. Because, like, imagine if developers have to learn 2 to 3 different vendor-specific approaches, and then later the company decided to move forward with another, the fourth tool. You could have to re-instrument the entire code base from scratch. So to avoid those confusions, these two project emerges. The Open Tracing and Open Census bring up a standard within the distributed tracing world. Eventually, these two projects competed for the same vision until in 2019, the merger happened of the merger of Open Census and Open Tracing happened, which resulted in the formation of OpenTelemetry. But before the merger, many people were quite sure about this, the classic XKCD 927. This was people were hoping that this is situation like this, that in order to standardize a certain amount of thing, to make now we have another standard sitting on top of that. So now talking about the current state of observability. In this era, the phrase like context is everything is really holds true, because the data we receive from our system is crucial for understanding the behavior. The modern observability consists of various signals like distributed tracing, logging, metrics, event, profiling, and there's a whole lot of data. If developers have to implement these signals using a vendor-specific solution, it would add a significant complexity and the risk of vendor lock-in as we scale. So this is where OpenTelemetry truly, shines. Building on the work of Open Tracing and Open Census, OpenTelemetry, aims to standardize what distributed tracing, but what Open Census does to distributed tracing. But now OpenTelemetry is doing the same thing also to the signals like logs, metrics, profiling, and many other signals. One of the, I would say, if OpenTelemetry would not have existed today, we could have been in a situation like this thing, because a software engineer or particularly a developer have to think about learning about a vendor-specific solution, and when with time or with the functionalities which could not be provided by the earlier tool, if the company switch to other tool, they again have to learn the entire stack and re-instrument the entire code base from scratch. So this is where I think vendor lock-in becomes a primary concern. So one of the best features of OpenTelemetry is the ability to correlate telemetry data. Like traces can be linked with logs and metrics via context, allowing us to drill down deeper and get more insights for the data. For example, a traditional monitoring approach might show like a spike in a metrics where a histogram or the graph or triggering an alert. You then click down, see that alert, and go to the metrics where it happened, and you see the related logs and tracing, providing a service-to-service level visibility that pinpoints whether an issue lies, like within a service level or across various services. I recently discovered that many people have this misconception about OpenTelemetry project. Some says it provides a programming language for monitoring. Other call it as just another observability tool that uses open, something like open source. But in reality, OpenTelemetry at its core, a protocol, right? OpenTelemetry is a protocol, a data format that's used to emit telemetry from our application to an observability vendor of your choice. When you instrument your application with OpenTelemetry, it does not need to know that which tool you are using now or you might be using in the future. It simply emits a signal uh, that be like a span or log or metrics, and the protocol handles the routing of the data to the desired destination using a URL and then API key from the vendor from your vendor. So in short, OpenTelemetry is a collection of APIs, SDKs, and tools that helps you to create a telemetry data in a vendor agnostic and a tool agnostic way. Today, we have the implementation for multiple languages like Python, Java, Go, and there are multiple languages, and Python is one of them. So if the choice of your language is not here, please reach out to us on the Slack or on the GitHub issues. We are happy to work with you. Uh, in Python, we have we have this signal status for the OpenTelemetry. For the Python thing, the traces and metrics are stable, whereas the logs are still in the development phase, right? While logging is still under our development phase, I would say. For logging in OpenTelemetry, we use a log bridge which connects your current logging tool to OpenTelemetry, ultimately outputting the data in the OTLP format. With this diagram, you can see that what is the influence of the OpenTelemetry project. Like it lies in the instrumentation layer. So instrumentation is like enabling your Python code to emit different telemetry signals like metrics, trace, logs, events, which could be taken care by something like this bigger block, which is usually called a OpenTelemetry collector, which is sending data to the backend. So now let's talk about the OpenTelemetry collector itself, which is like a heart of OpenTelemetry project. So the collector takes care of your telemetry data and export to it to your vendor of your choice. While you can configure an agent to send telemetry data directly, it is not generally preferred, but it is usually recommended to add a collector in between, because the collector can receive telemetry data in various format, not just OTLP, to enrich it with resources information. For example, like from a cloud instance like EC2 instance, and annotate metrics or trace data. It can also pull in the Docker and databases statistics among other other things as well. Collector lets you process the data as needed. You can filter or group or batch or compress data to reduce your network egress cost also. So they also supports a sampling technique, which is present in the processor part, where you can sample your data based upon whether you want to sample it around the head-based sampling or tail-based sampling or even probabilistic sampling to lower the volume of data exported. Finally, the collector sends the data to your desired backend, like whether that means writing to a file or sending the data to a Kafka, or using a various pub subsystems. So in short, the OpenTelemetry collector can offer most of the functionalities required for the modern telemetry pipelines. Uh, Note that there are two OpenTelemetry distribution. The first is the core, and the second one is the contrib distribution. The core distribution includes the basic features like the OTLP, but does not provide any specific processor or exporter. However, if you want to experiment with the additional functionalities, you can check out the OpenTelemetry collector contrib repository. There is also this tool called OpenTelemetry collector builder that helps you to build your own custom collector binary containing only the components relevant for your production environment. Now, moving ahead with how we can set up an OpenTelemetry within our Python application. So, you can install it like using these commands like pip install OpenTelemetry SDK within our application. Now comes how you can set up the trace exporter, like how it can enable us you to generate their traces within your application. So this is the common like sort of line which is used across every language. You can just copy and paste this line within your top of your application and it starts. Now moving with how you can create a span. So you can generate a span within a specific function or within within a function where you feel that getting visibility or having or chances of having a failure is very much important, or like at that places. So this is sort of, you can create a span within your application, and this is how you can link the span. The thing we talked about earlier is like the mechanism we called context propagation. This is that thing. This is how you can link different span within a service, or maybe multiple services at the same time. This is how you can record a span exception if something bad happens, or you just want to keep a note of something that is something really happening there. If it's if it's an exception, why not to have an let's see what is happening in there. So now comes it's the part of the project itself. It's called OpenTelemetry Semantic Convention. This project offers something like this thing, which is a standardized way to represent metadata about your system. For example, when setting up a multi-cloud environment, the way IP addresses, databases reference, or even host names are represented, it can vary on the cloud to cloud provider. So OpenTelemetry Semantic Convention ensures that regardless of your application, your runtime, your cloud, or even your container, the data is aggregated using a consistent attribute. This standardization not only makes the project more powerful, but it also paves the way for the future monitoring and observability, future tools. In the future, if we want to run some machine learning algorithms in there, so semantic convention would be very I would say beneficial, because our model would be able to recognize that, hey, the data comes from this K8s cluster or this container, or like any other sources we wanted to, and then according we can sample the data, and then we can use the data according to our need. So this is OpenTelemetry, and this is how you can add semantic convention within an application. So semantic conventions are for like traces. We have certain conventions for metrics. We have for logs and for other resources as well. So the vision of OpenTelemetry. So with the rise of OpenTelemetry as a universal standard framework for observability data, we have seen a shift from vendor lock-in. That in the past, vendor competed by offering their closed SDKs and agents that requires developer to instrument their microservices. Now the focus has shifted from that part to a more functionality-based observability. Like choosing a vendor is now like based upon the quality or the cost or the reliability of the solution. The OpenTelemetry makes our life easier, but by giving us the standard, like so that your future, so that if in the future your company wants to switch to another tool for the sake of like for the sake of cost, or like any other thing, you can easily do that. And as a software engineer, we often have to deal with multiple tools to get visibility, and sometimes we wish to use a single tool that does everything. However, that's like that the thing. And OpenTelemetry based observability approach can give you flexibility that depending upon your requirement, you can be able to choose what you want to, how you want to get visibility into a system. So the vision of portability, being able to move quickly based upon your needs, is the heart of the OpenTelemetry project. However, there's this one thing which I sometimes hear from few peoples where I go, like they say that some vendor offers a more stable SDK compared to the OpenTelemetry for some of their specific use case. While I think that this may be true in some cases, but it raises a question that is OpenTelemetry perfect? Well, the answer depends on your use case. Think of Kubernetes. Was it stable from day one? But I guess, no. But the entire community collaborated to evolve it. The OpenTelemetry has been evolving since 2019, and by 2025, it has evolved itself into an advanced project. And now we support multiple functionalities across multiple languages. Now, the next step, right? The next step for us is to contribute to the project and make it even more better for today or in the days to come. I see a very bright future of this project in the future. So, like before I closing my talk, I would like to know from your end that if your organization is not yet using OpenTelemetry based observability, what are the reasons that why aren't you switching or consider to be in that particular state? Like, portability at scale is crucial. It helps you, it helps you to increase, to be more reliable, to be more efficient in terms of cost, or maybe in terms of functionalities. So, I would really like to know if you or your organization are using those things, like not shifting to open standards. I would like to know the reason for that, and because it's a part of our, how we can evolve the project at its very core foundation level. I would love to know your thoughts on that. So, if you want to get involved in the OpenTelemetry community, this is the GitHub. These are the GitHub links for that, where you can see and you can talk with the people in there, and just play around the project to get started with that. So, thank you for having me. I hope you learned some valuable things from this session.